Okay, we go to part C and part D. Part C, we said that upon B, and then a line through B perpendicular to the plane intersect the plane at a point C. So find the position vector of the intersection point. So we know this point OC is represented by the original point plus C to the normal vector here, right? And then it asks, is required that this point is on the plane. So we know that, okay, -3 12 plus 2c 2 minus c dot 0 2 minus 1 has to be equal 7. So you have the equation about c, you just expand them, and then you will find out, oh, c is equal -3. Substitute it back, and then you will find the position vector of c, OC, okay, and it is equal -3 12 minus 6, so it's 6, and then 2 plus 3, so it is 5. So it's -3 6 5. It is the answer of C1. And next one, you want to find out the magnitude of BC. So you remember what is BC? BC is OC minus OB. So OC is here, OB is here. Okay, so you just subtract these two, and then you find it out. They are 0, -6, and 3. And finding out their magnitude is just like a 3-dimensional Pythagoras theorem. Okay, so it's a square root 6 square plus 3 square. So numerical value decimal number is excellent. So you got it is 6.71. Last part is a little bit tricky. C or D. Find out the refraction of point B in the plane pi. So remember, plane is here, point B is here. So perpendicularly it is on C, okay? And then one more time behind it is B dash, okay? So same distance perpendicular behind. So it means that we have to substitute 2C to this equation because it's 1C to point C and 2C to B dash, okay? So for part D, yes, you got it. It should be -3 12 2 plus 2C, okay, it means -6 0 to -1. And then after the calculation, you find out it is a -3 0 8, but be careful, it is a vector form. And then you said that the point B, the refraction, so you do write it down in the coordinates. So it's a -3 0 8. Got it? Well done.